I want to say thank you, everybody, for coming to yet another webcast from Active Countermeasures and Black Hills Information Security. As always, the webcast is brought to you by Black Hills Information Security. Hey, you need a pen test? We do those. You should check it out. Also, it's brought to you by Active Countermeasures. Hey, you need a hunt team? We do those. And if you would like a demo, as always, for Active Countermeasures AI Hunter to be given to you by Chris Breton or myself, just want to hang out for an hour, just type in demo in the questions, and we will be happy to do a demonstration of Active Countermeasures AI Hunter. Now what I need to do is I need to make one of you, Bo or Mike, a presenter. So which one of you are going to drive the slides today?
Mike is.
Mike is. Awesome. So we're going to go like this, right click, make Mike a presenter. All right, everybody. So thank you very much for coming to this webcast. There's been a lot of new classes and different things kicking out about recon and whether or not recon, the state of recon, can actually be advanced. And I think out of all the different aspects of penetration testing and red teaming, recon is one of those aspects that changes the most quickly. And I think attending as many webcasts as you can of different new and advanced techniques is really, really key. And Mike and Bo have been doing a lot of research on how to do recon in a faster, more efficient, and absolutely horrifying way. And this is all part of what we do for some pen tests and then also for red teams as well. So with that, I'm going to hand it over to Bo and Mike, and they will take it away. Thank you so much, guys, and go for it.
Thanks. All right, good deal. So I think we have a pretty good idea of what we're going to be getting into here, but I think, Bo, you might want to take this first.
Sure. Yeah, so I always like to preface this part of this this particular presentation with the first half of this entire thing is what I kind of consider like a recon, almost like 101 kind of a refresher of our like kind of a methodology we kind of go through. A lot of it is stuff that I feel like is well known, but there might be some tidbits in here that are new to you if you're listening to this. So through this talk, what this is it's a recon talk with a new attack path kind of tagged onto the end of this presentation in regards to a newer password attack and a new way to identify information about your targets. So we're going to kind of go from knowing absolutely nothing about an organization to what I kind of consider stalker status a little bit. Like it's scary, the amount of information that we can get. And it's one of those things like, when we're doing a pen test, we don't necessarily need to know your social security number, but it's possible to get it in a lot of cases now. And it adds an additional layer of something we can use to target your employees. If you're an organization who is somebody who's going to be targeted by an attacker, there's a lot of stuff we can look at. And we're going to walk through basically all of those aspects of leading up from knowing nothing to learning about your external attack surface to who works for your company, and then ultimately kind of trying to tie in how all that works whenever we're looking at attacking your company. So the main reason I want to kind of lead with all this kind of like initial recon is that I believe it really kind of reinforces what happens later. Like I don't think that if we just dove right in and started, showing you all this new stuff, that it would really make as much of an impact as if we can kind of show you all the steps it takes and the amount of information we can gain throughout this entire process.
Yeah, it's going to develop the attack path pretty much, right? Mm-hmm. So kind of without it, that's all right. So about us, obviously, we're both here, red teamers at Black Hills. I was involved with the OWASP Orlando team. And with Bo doing Tradecraft Security Weekly, and then obviously the CoinSec podcast, and so pretty much the same stuff. So attack surface recon, Bo, this is you.
Yes, this is me. So like I mentioned, this is we're going to scratch the surface of the external network at this point. So when we look at targeting an organization, our first step is first off, what are we going to actually look at attacking, right? So we got to build a solid target list. We have to really understand what technologies is your organization using, how many hosts do you have, can we discover things that you might not even really realize is still there, like things like legacy items. But in reality, there's three main things that I personally try to look for up front. I want to know, how are your employees remotely accessing your network? how are they accessing email? Because pretty much every workforce on the planet has to have a way of communicating. And then if I can gain an insight into what security products you're using externally, that just adds so much more that I can use to exploit on, or whenever I'm going to try to build payloads, I can use that information to craft stuff around those specific products. Like if I see that like maybe one of your security engineers is on LinkedIn and he starts talking about, I'm an expert with, Blue Coat web proxies and, expert Symantec, AV deployer or something like that. That stuff helps me as an attacker understand what you guys are using. I've actually seen a number of companies lately that actually like post up like what products they use. Like they'll be proud of the fact, right, that they're using things like Carbon Black, or they're proud of the fact they're using more advanced softwares in terms of protecting their networks. And all that information is really, really important to us as an attacker. So let's move on, next slide. So the first thing that we look for, this is like the baby steps, right? We want to look at understanding what domains you have, what top level domains and what subdomains can we figure out. So a lot of this can be done through basic stuff like just Google dorking. So basically going to Google, going to Bing, going to the Chinese search engine Baidu and doing things like site : domain name and trying to discover what domains you have out there. Throughout this entire presentation, each of the slides has the associated reconnaissance modules attached at the bottom as well, so that if you want to go run this, we do this all the time in reconnaissance because the modules are built to basically do all this enumeration already for us, and it just makes it a lot easier. So the modules are out there. So the modules for this particular slide are the Bing Domain API, which actually utilizes an API key that you can get from Bing to perform web searches as well. So netblocks. Hurricane Electric is a company that has a great netblock discovery site. So bgp.he.net. You can go there and you can search for ASNs. MX Toolbox is a site that I use all the time whenever I'm looking up a netblock associated to a specific IP address. So if I go and I want, like, let's say that I look up your domain and I understand that this IP address is associated with your domain, I can take that IP address, go to MX Toolbox, and then that will hopefully be able to translate it to your associated netblock and give me the rest of your infrastructure. One thing to kind of note here that we run up against a lot is when organizations are using like third-party hosting, like so they're using things like Rackspace or using like some sort of hosting service where they're buying IP space that isn't necessarily associated with them specifically. Sometimes that can be a little bit harder to kind of attribute to an organization, but we can kind of go through the process of enumerating domains and still kind of tie up IP addresses that way. And then the other thing to note here is that each region has its own internet search registry list as well. All right, so in terms of subdomain discovery, there's like hundreds of tools out there, I think, that do subdomain discovery. It seems like there's one that comes out each week. I mean, there's such a plethora of subdomain discovery tools, and they range from performing different types of lookups to brute forcing just domains across the internet to looking at certs to all kinds of stuff. But some of the main ones we use are Shodan and Census. So Shodan is a site that they scan the internet all the time and provide a search engine of sorts for ports that are open for sites. Census does a similar thing. DNS Dumpster is a great site for looking up domains. Hacker Target and ThreatCrowd both, again, great sites that we utilize all the time. And it's a lot of these are fairly similar sites, but we get back different information from them. So they're doing slightly different stuff, which is interesting. I like to have like kind of a, go ahead, John.
So Jeff had a question. He said, if a company owns multiple brands, multiple domains, where would you be able to find all the domains or many of the domains associated with the organization?
So yeah, so we'll get into looking for multiple top level domains in a second. So I think that's what he meant there, right? Multiple top level domains, right? Yep. Yeah, so when it comes to the top level domains, this specific part of it, I'm looking at just enumerating subdomains for like one specific TLD, right? And then in a second, after, I think it's actually the next slide after this, we're gonna talk about trying to look up multiple top level domains. But one thing I do need to note here is that subdomain brute forcing is very important too. So like, we might not be able to get all the subdomains just from these sites. So let's go ahead and just brute force them ourselves. So there's a number of lists out there that you can use. So just perform DNS lookups for various subdomains for a specific top level domain. And you can, gain you can learn more about the subdomains through that. Let's see. So additional TLD and subdomain discovery. So one of the main ways that we find additional top level domains is through certificates. And that's basically through certificate transparency. So cert.sh is one of the sites that provides a service where you can basically search for a specific domain, find SSL certs attached to that domain, and then a lot of times within those SSL certs, if they have used them for multiple top-level domains, you can see that within the certs themselves. So there's been a number of tests we've been on where we will pull a single cert for a website, and it contains other top-level domains in that same cert. If that makes sense. That's one of the.
They're basically taking the certificates and then like parsing them and then databasing them in a Postgres database. They actually, when we were using cert.sh recently, and I stumbled across a forum post where the developers behind it. Now they've open sourced all of the tools that they use as well, but they actually made public read access to their Postgres database, so you could just go in there and query it directly. So it's really nice.
Yep. Yeah, and then so once we get those new TLDs, rinse and repeat, right? Like go back through the entire process again, start looking for more subdomains, looking at the netblock spaces, and just try to gain as large of a host list as we can, essentially.
Yeah, because once you get these domains, you'll start seeing on cert.sh that they may have registered another top-level domain and sharing certificates with ones that you already know about. So referencing it when he's saying rinse and repeat and go back through the netblocks is because you kind of want to try to make sure that you could parallel both domains to the same netblocks. That way you could identify whether or not it's at least within scope of your infrastructure.
Mm-hmm. All right, so the next thing is looking at cloud services, right? So we've looked at the attack infrastructure that a company's hosting themselves. What other cloud services are they using? Are they using things like O365, SharePoint, Skype for Business? These are very big targets that we look for on every single assessment because, which I'll talk more about later, is that we're looking for portals that have Active Directory connectivity for the most part. Because if we can attack that, we can perform password attacks against your users. And so one of the ways that we can find out if you're using O365 is just go to outlook.office365.com and try authenticating with like test@yourdomainname.com. And if you use O365, it will simply redirect to your own portal. That's just the way O365 is set up. SharePoint, similarly, you can check for like companyname.sharepoint.com, and a lot of times you'll find that they utilize SharePoint based off of just the subdomain there. Find Skype for Business, so link discover, similar to auto discover in the way that OA works. So linkdiscover.domain.com will point you at the link or Skype for Business servers that a company utilizes. And again, all of these are Microsoft services, and we heavily target these because they have Active Directory connectivity.
So a couple of questions. The first one was, how does cert.sh collect certs?
Yeah, it's using the certificate transparency projects that are out there. So like Google, for instance, makes all of them that get registered available. So if you looked up like a certificate transparency, you'll see a lot of different projects that monitor it. There's been some where they monitor S3 buckets for they monitor their certificate transparency project for S3 buckets to try to discover misconfigured ones on the fly. There's a lot of really cool projects that leverage certificate transparency. So.
And then another question, whenever we're seeing a lot of organizations moving to things like Office 365 and Google Business, a lot of organizations speak of like zero trust models where there's no trust internally, everything goes to the endpoints in the cloud. Do you think that zero trust model is more or less secure? People are moving everything into the cloud, getting rid of Active Directory. Is that a more or less secure approach to an overall architecture, especially for new organizations?
So, we've done assessments against both, right? We've done, hundreds of assessments against both types of infrastructures. Some that utilize AD, which I would say is the majority of companies that we attack, and then a number of them that don't, right? That just straight up don't have Active Directory, and they're very different, obviously. But I would lean more on the side of if you don't have Active Directory, it's harder to manage. From an administrative standpoint, which can potentially make your endpoints less secure. But at the same time, without the Active Directory infrastructure in place, you have users who are now basically creating their own security policies of sorts, right, on their own endpoints. Like they're basically following their own set of restrictions, which can be just honestly based off of obscurity alone. It can make it tougher to target. So I think there's definitely benefits to both.
I was gonna say having the hybrid, like using ADFS for Azure and then AD for on-prem, and then synchronization. We've seen a lot recently too, an uptick of kind of compromising the system based on the configuration. So whether it's like using the ADFS syncing connector or just the misconfigurations of how they have it, just because it's a hybrid model, I think it makes it a little bit more difficult to manage.
All right, so then other cloud services that we see a lot at Google. So honestly, like back to your question about non-AD infrastructure companies, we go up against Google infrastructures a lot, where companies are utilizing Google for the main stuff, right? Like for document syncing, to email, and they don't really have like an infrastructure in terms of their endpoints. And a lot of times with those companies, we're looking at targeting their Google infrastructure. Like that is the target. And to find out if a company's using Google, it's similar process to the way we attack O365. We can basically just put in a valid company email, and if it's a valid email, it will redirect to the authentication portion of that account. So like it'll ask them for a password.
So
Box.com. Oh, sorry, go ahead.
Martin just asked a question. How would this work on whitelisting of the ADFS, since we whitelist on ours, meaning not everyone can connect to it?
I'm not sure.
I don't know. I will say whitelisting on ours usually doesn't work that well. I know that some organizations try to establish that accounts can only be accessed from 9 to 5, and
hours, like as in time.
Yeah. So like, oh, I thought you meant like hours. Okay.
Yeah.
So like using conditional access rules, I'm guessing.
Yeah, time based on that. I just, I remember years ago they used to tell everybody to shut off your computer at night to stop hackers, and that was back in 2000. I kind of see that as the same approach, and I don't think
because hackers only hack at night, right?
Yeah, right. Well, seriously, I used to have managers that would say things like that. So I think that those types of whitelists are not nearly as effective as some people would think they would be.
I agree with that. So go ahead, Mike.
I was just going to say I've ran up against conditional access rules where we were able to compromise credentials from a target employee at an organization using phishing, like Cred Sniper, and went to log in to authenticate, and it turns out that the conditional access rules restricted them from logging in based on location.
Yeah, Martin just asked that as a follow-up, location or IP address. I think that may have a little bit more, that might make a lot more sense. Like if your business only runs in Kansas, or everybody's in the United States, you might want to restrict access outside of that.
Mm-hmm.
Yeah, definitely.
Some companies add two-factor authentication too for when employees are outside of the quote-unquote office space.
Oh wow, we just had new employee Bill come in with an answer too. By the way, everybody say hi to Bill. He's helping us out on the active countermeasure side, as Mike and Bo are like, who is that? Amazing.
I was like, is that BB?
Bill, smooth voice. That's Bill. So nice.
Hi, Bill.
Great job, FNG.
Awesome. All right, so back to cloud services. All right, so Box.com, this one is actually, I feel has become more and more interesting, especially over the last couple of weeks, because there was a report done where they were able to find that Google was actually caching a lot of these publicly available files that companies were hosting on Box.com. No. Yeah, so Box.com has a similar problem, right? Like the subdomain companyname.account.box.com to locate the company you want to attack. You can search for that on Google, cite, then with that URL. And so that's one problem, right? Like the Google caching part of this problem. But Google has to be able to find those to do that. The second problem is that with Box.com, you can create your own customized names for files that would just be tagged on to the end of that. And that makes it, that creates a brute forcing problem. So what was released I guess a week or two ago now, was a tool to basically brute force those file names on the end of the URL there. So now you can basically just brute force potential files. Like somebody called a file like, secret documents or, tax files or something. Like you can brute force all of that now, which is kind of interesting. Amazon AWS, looking to see if people are using S3 buckets. Basically just look to see if web resources, when you load a web page, are pointing at that stuff. Anything to add there, Mike?
Yeah, there's just, so whenever I guess if you're using AWS for S3 as a CDN, right? So the images, the JavaScript, the CSS files, sometimes they load directly from the CDN when they're in use. And so when you kind of are viewing the page, you can kind of get an idea. I think there's some plugins too for Burp. If you're browsing like pages and you see some stuff, you could kind of identify where those S3 buckets may be. And then I mean, there's projects out there where they brute force them using like domain names or subdomain names. And then you can kind of just enumerate looking for misconfigured buckets. Amazon has made a pretty big push on streamlining configurations for S3 buckets now, so the policies aren't as lax as they used to be. So you have to kind of go to like these other alternative AWS services in order to find misconfigurations nowadays. But S3 buckets are still a huge deal.
All right, next slide. Okay, so after we've kind of collected all of that information, right, about the external attack structure, right? So we're looking at like all the hosts at that point. Now let's figure out where can we log in. So let's look for interesting files and let's look for login portals. So next slide, please. So, you know, now that we've kind of done this passive discovery of where the portals are, we can go into more of an active mode, which, you know, all of you are familiar with port scanning, I would assume. You know, basically your basic nmap scan for just web services is typically what I run right up front. Something like, you know, 8443, I threw 2381 in there because that's HP System Management homepage, which has, you know, historically had a number of vulnerabilities, 8080, 8443, just typical web portals. And then we could, you know, go and manually navigate each of these results with a browser, or let's go to the next slide. We can use an amazing tool from Chris Trunzer called EyeWitness, which does screenshotting of these portals. Hey, there's a poll. Hey, everyone. Sorry to interrupt your presentation. I suppose you should answer a question at this point.
A lot closer than I thought it was going to be. This is the way they say that this is the way to increase engagement with your audience. So, so there we go. I wasn't expecting it to completely hijack the entire webcast, yeah. But I think we have enough votes to say definitively that Bo should not shave. So I'm going to close this poll now and give you back access to the screen. That didn't go well at all. So his legs are fine. No need to shave. His face or something else.
Nice. Oh my gosh. Okay.
Oh back to EyeWitness. Should he shave himself or Mike?
Whoa.
Yeah. That's weird.
Next one.
Right, so there's a lot of times we come up against like companies that have thousands of web portals, right? And we could literally open up a web browser and go to each one and navigate them, or we can just screenshot them, have it put in a nice HTML format where we can just scroll through it and look at pictures, essentially, of each portal. And what I typically do is I create like a secondary list of interesting web servers from that list. That way I can use it for this next portion, which I'm about to talk about, because you know, like we you know, when you're looking through these results, a lot of times you're gonna get, you know, a ton of like IIS, just your standard pages. You're gonna get a ton of just, you know, blanket, you know, Apache pages. There's a ton of like things that just are the same across organizations, if that makes sense. So try to create a list of interesting stuff. And then we go into this process of looking at brute forcing files. All right, so this is something that was actually written by Steve Borosh for internal pen tests. This is a script that he wrote called Find-Fruit that essentially you pass it a netblock list, and on an internal network, it will go and just look for a specific set of like certain interesting files. So things like your typical Tomcats, your Cold Fusions, that kind of stuff on an internal network. I took that and I modified it because what I wanted a script similar to that I could pass a URL list and a file list. And that way I can now brute force these directories and files at scale across thousands of web servers. So we have a short demo for this one. All right, so let's play this. All right, basically, it's a PowerShell script. You feed it a list of URLs. So we've got this list that we've kind of gathered. This would be the interesting list that I gathered from EyeWitness. And you can feed it a ton of these. This is basically the list of files that I want to brute force. So this particular list has 6,000 files on it. We're going to give it a timeout of about 3,000 milliseconds. A number of 10 threads. So it's going to hit, it's going to spin up 10 different sessions essentially to brute force these files. And we're only going to print out anything that was found.
And people are asking already, where can they get this tool?
It's on GitHub. Hold on. I'll show you.
It's on GitHub, right? Got it. Okay. CJ's got it.
Can you pause it for a second? All right.
Questions
so,
are coming so fast, I can't keep up with them.
Okay.
Go ahead.
All right. Yeah. So it's actually part of Steve Borosh's Find-Fruit module. So it's actually in his repo, which I can copy the link to that in a second, and I'll paste it in. But essentially, what you just saw there was a very quick version of the way this would work, right? So it had a total of 30,000 requests that were sent. I sped this video up for the sake of not waiting here for 7 minutes, but that only took 7 minutes to do that. So essentially, I fed it a list of targets, fed it a list of URLs. It brute forced 30,000 files across them in 7 minutes, and you can kind of see, you can play it now. We got some results back, so like that's some typical Cold Fusion stuff. There's some EWS out there. What's that?
Secret.
Yep. Secret, OA, some WebDAV stuff, WordPress. But essentially, like, you get the idea, right? Like this is something like, instead of just taking each specific URL and running something like Derby or Dirbuster against those specific URLs, we're now doing this threaded across multiple sites.
So it's faster, multi-threaded. You can hit it across multiple systems. That's kind of the advantage over like Dirbuster.
Exactly. Yep. Yeah, because I wanted to do this. I didn't want to just say, okay, run Dirbuster. All right, next server, run Dirbuster. Next server, run Dirbuster. Right? Yeah.
And have you used something called AMAS? I haven't heard of this, but James was asking how does it compare to AMAS? I haven't heard of that.
Yeah, I'll have to check that one out. So now that we've kind of learned what portals we want to attack, the next part of this entire attack process is figuring out what information can we now utilize from the internal network. Can we actually remotely gather internal domain information remotely? Next slide. Okay, so on pretty much any vulnerability scan you ever run, it will tell you that information disclosures are either low or informational, which I totally disagree with. I think that information disclosures can be critical, especially to an attacker. So think about this. If I'm an attacker, if I don't know what your internal domain name is, and if I don't know what your username schema is, how am I supposed to perform password attacks externally? Potentially, if there's like an email portal, sure, I could use like an email address for that. But in a lot of cases, what we're looking for are Active Directory login portals. So things that are accepting like NTLM-based authentication that utilizes domain/username. And so I think that the process of just identifying those names alone is critical information to an attacker, right? It might not be critical in terms of a vulnerability because nobody's going to exploit that, right, to you as an organization. But to me as an attacker, I have to have that information. If I don't have it, how am I going to attack?
A lot of times, I think a lot of times, real quick, is the reason why we see it's low too is because it's a vulnerability scan that finds some sort of information disclosure, and it within itself tends to be a low finding because it's not exploitable, right? But when you are an attacker, those definitely are elevated.
Yeah, so in order to perform a successful password attack, we need the valid username format, right? And then we need a portal that has a high probability of that the users can authenticate to. Because a lot of times externally, we're attacking very large organizations that have multiple different types of like email portals and VPN portals. Like I've seen companies that have 50 different VPN portals, and it's hard to really understand which one of those is the one that every employee can actually authenticate to. So we have. Yeah, which one's the good one? Which one's the one that has the high probability? So those are two very important things we need to look at. So this is a vulnerability that we disclosed to Microsoft 2 years ago now, and it's something that they don't want to fix. It's a problem in the way that they handle authentication attempts, and it allows for username enumeration. So this is part of the process for us identifying what your username schema is. So with OA, Outlook Web Access, when I perform an authentication attempt to that portal, if I utilize a username that is wrong, it will take a significant amount of time differently than a username that is right. So it might take like 600 milliseconds more for the application to respond to me if a username is correct. So I can identify which ones are incorrect and which ones are correct. So I can go through the process of, single initial last name, last name dot first name, all these different types of formats, and try to identify which one is the correct one purely based off of response time from the application. And you can use Mail Sniper to perform that attack. It has a module for it. Next slide. Yep. The other thing we look at a lot is metadata. So Jason will like this one because I gave marketers some crap in the last time we talked about this. But basically the idea here is that publicly available files that are hosted and things that are hosted on your web application, if I can pull those down and I can extract metadata from them, I can a lot of times gain information in terms of like what your usernames are and the applications that they're utilizing. So to give you an example, a lot of times marketers, Jason, I don't know if he's still on, I hope he is. But a lot of times marketers, yes, there he is. A lot of times marketers will create documentation like, the shiny new PDF that details all the cool services that your company does. And they'll just post it on the website. And then that way people come by and they say, oh, look at all these sweet services this company does. But a lot of times, if that person that created that PDF did not go and actually extract metadata out of them, their username is attached to that metadata. So externally, me as an attacker, if I can just go find those files, pull them down, pull the metadata out, I now have your username, and I can use that to basically build a list off of.
And Martin just asked a question. He said, what would happen if we just use a sequence of letters and numbers? How would this work then? And I think, honestly, it would depend on the length of the numbers and letters. I mean, whenever you're creating user IDs, like I remember at Northrop, we would have a number. It would be like E and then a series of numbers. And that would be my logon, right? That would be my account. But it wasn't long enough that it wasn't brute forceable. I think that the length matters quite a bit because we can actually still brute force it, correct?
Yeah, so I actually had a company similar to that, and it was 3 letters, 3 numbers. So like that's a very short list of brute forceable possibilities, right? And what I did is I actually was able to figure that out through this exact attack right here. So I used PowerMeta, which is a PowerShell tool that I wrote, which is basically it's a very similar set of tools to Foca, or if you've heard of Goka, which is a newer version that's written in Go. It basically does Google searches, does Bing searches, finds these files that are cached on those sites, goes and downloads them, pulls the metadata from them. And so I did this for an organization. I figured out their username schema was 3 characters, 3 numbers, and then I just did exactly what John said, brute force the entire space just to figure out what that list is, and then use that username enumeration vulnerability on OA to figure out which ones of those are correct.
Bo, how much does a company's policy to lock out accounts with bad password attempts impede your progress?
So when we do password attacks these days, we're doing password spraying for the most part. We're not doing brute forcing, right? So if we're not doing brute forcing attacks, then the password policies don't matter, right? I mean, because we're trying like 1 or 2 attempts in the span of a day, I mean, there's a lot of organizations that, like, actually, I think the largest policy I've ever seen is a day, a window of an observation window, where like they'll create a threshold of lockout attempts you can perform in a given amount of time. And I think the largest I've seen is a day. So as long as we're doing like 1 or 2 attempts a day, there's not a whole lot of risk there.
Cool.
Okay. Yep. So, all of these attacks, right? The one problem we have is IP address for the most part, right? Like as attackers, that's the one thing that you as the blue team are going to typically alert on is all right, so this guy is scanning my site, he's doing password spraying from this IP, let's just block that IP. Well, there's been a few different types of tools out there that can help with kind of pivoting your IP space, but some of them don't really work that great. Like they do maybe up to 12 IPs, at a time. We had Proxy Cannon, which was cool at the time, but you can only spin up a few at a time, and so that still doesn't give you real evasion, if that makes sense. So Mike, what's the fix for this?
Spin up a bunch of Russian VPS servers and chain them all together. And I'm just
Kidding.
Yeah,
Kidding.
don't
He's
do that.
kidding, everyone.
I'm just joking. No, so like it used to be back in the day, like if you're from like any time before like SOCKS was a really big thing, they used to have these things called Wingate proxies, where you could scan the internet for Wingate proxies, and then you'd have a million of them, and you could just use those, which were basically SOCK proxies anyway, I think, but before SOCKS got really big. And I liked Proxy Cannon. Proxy Cannon is actually a really good tool. It spins up EC2 instances and then routes all the traffic through it. And then Cred King, what you were saying was the 12 IP limits, and that's because Cred King is built using the AWS Lambda, which is really cool in what it does, serverless compute, but you're still limited. And so what we did was we came out with this tool called FireProx. We released it a couple of weeks ago now at B-Sides Orlando. And then the idea behind FireProx was I was informed from Ralph May, a friend of ours, that if you used AWS API Gateway, that it would actually rotate the IP with every request. After some dialogue after the tool came out, I learned that this actually was old. In 2016, some people came out with the tool and released it at Black Hat Arsenal as a portion of their tool set. It just didn't get any headlines. But it's a really fascinating technique. So it's using the AWS API Gateway. And what you're doing is you're basically setting up an HTTP pass-through proxy. And so if you're familiar with like the HTTP protocol, you'll know the gets, and you have posts, and you have heads, and you have options, and all these different methods. This does basically any of them. So you can set up any to any. And what you do is you spin up this API Gateway proxy, you point it at a URL destination, and it just has to be, doesn't have to have the full URI. It could just be www.companydomain.com. The entire URI on the end of that, so all the file names or the directories, all the post parameters, all the headers, they get sent directly to that destination. And when it makes the web request, it's actually using another IP address with every request. So let's say that you sent 1,000 different web requests, it's going to rotate them. Now there is, depending on the region, there is a finite number of IP addresses somewhere. But if you use like US East 1 or US East 2, I rarely run into a duplicate. And if I do, it's like minutes or hours later, and it just so happened to be like coincidental. But it's really cool technique. And so FireProx basically spins up a URL, and it provides you with the proxy URL for the API gateway. And then you could scrape, or you could do password sprays, or you could crawl and use some of those tools. The other cool thing is if they're using CAPTCHAs or WAFs or any sort of detection capability on the IP, a lot of times you'll see some of these more sophisticated infrastructure where their security teams are basically looking across all of their IP space and then correlating them back to the IP request. So if you make a web request and then you also try to authenticate and then you also hit some mobile app endpoint or some MDM endpoint, then they're able to say, hey, wow, this is weird. This IP address is touching multiple different IP addresses. Let's just blacklist it. Or they get smarter and they say they might be using a proxy, so let's monitor for the X-forwarded for header. This originally, when we released it, we had this problem. And so we put out a $100 bounty for the first person that could find a bypass for it. And Fred Reamer actually came out with it within a couple hours. And what he did was he overwrote the X-forwarded for in the API gateway. And so you could basically spoof the X-forwarded for by passing in your own custom my X-forwarded for header, and it would automatically reroute it. And it was super fascinating. So with that, I have a little demo here. You're
Ready just in case. Okay, we do not need the poll, by the way. By the way, I like the fact that you're using Fish. That's awesome.
Yes, Fish is amazing. So in the top screen, I have FireProx. In the bottom screen, I spun up a web server. It's basically just a custom domain. It's BHIS webcast.ezrareport.com or something. So what we're going to do here, before we start it, because it goes kind of quick, I'm going to launch a custom web server written in Python on the bottom screen. All it's going to be doing is listening for web requests. It's going to be printing the request as it comes in. And I also print the exported for below it, so you can kind of see, get an idea for it. And then in the top screen, FireProx is going to run, and we're going to kind of walk through a few of the different techniques that FireProx does on creating new ones, deleting them, and listing them out. And so I'm launching Python hacks.py. I'll show you a copy of what that code really is. It's super lightweight, but basically all it really does is it spins up a listener on, it binds to 0.0.0.0, which is on the external interface on port 80, and then it makes the web request, it prints it out, and then it prints the exported for it. Basically all it does. And then FireProx, we run fire.py and just by itself, and you'll see it can take an access key, secret access key. You could use sessions. We had another pull request for profiles, so you could use AWS profiles. And then there's a number of different commands: list, create, delete, and update. So the first thing we're going to do is we're going to spin up a create URL and point it at the bhis webcast.ezrareport.com URL, which is the one running on the bottom. And AWS API Gateway is going to give us back this long URL that has some custom, basically a custom Amazon URL. So anytime we make a web request to that URL, it's actually going to be sent to our web server, which is on BHIS web. So I have this brute.py file that I wrote really quickly that does exactly what Bo was talking about earlier. It reads in a word list, and then it just attempts to concatenate the URL with that file and check for the results. It just loops through. You'll also notice I'm passing in the exported for, and I'm spoofing localhost as who actually made the web request. So if their SIM is up there running, it's going to see a bunch of 127.0.01 requests. And if you look on the far left on the bottom, this is just going through and enumerating it, and the IP address is changing with every web request, and you'll see the exported for is 127.0.0.1. And this could technically be anything, right? You could take, I'm gonna pause this real quick. You could see on the far right the get, it's get/2004, get 2001. It's enumerating all of these, looking for these files in there, and it's making a unique IP address request with each one. So if they are blocking on the IP address, then they're just blocking a bunch of AWS API IPs, which technically would be a lot of them. So I don't think they would, it's only making one web request, so they're probably not going to block on one. If they're blocking on exported for, which we've seen before with like fail to ban and some of these other tools that have plugins for blocking exported for, they're going to block 127.0.0.1, which is localhost, or we could have set this up for the actual web server. We could have did it for Cloudflare IP addresses. We could have made it random, so it's randomized as well. But this was just a simple little demo kind of showing how each of the IP address change. So I just canceled the FireProx brute up top. And if you do,
quick question. Oh, wait, somebody just said how much the API costs, would it cost for the API key to do this?
So it's super cheap. I did some math. I think it was like 1 million requests with an average, I forget what it exactly was. I think it was like 20K payload size for 1 million requests a month, and it was like dollars. It's very cheap.
Mike, didn't Dakota just have like a $400 bill or something for something?
Yeah. So Dakota rolled this into his scraper.
Which means I'm going to have a $400 bill.
So yeah, Dakota rolled it into his scraper, and because he's a data connoisseur like me, we collect data.
So you guys with like wine glasses. What did you invent? Well, that's fantastic. That's a vintage 2019.
Data smells bad.
What? Not a connoisseur.
So, but his payload sizes were massive because he was downloading these big chunks of JSON. And so it spiked it up. And the other thing was he let control of it. So he just let it ride and he forgot about it and came back and was like, oh, yeah, that's a bad thing. So it's relatively cheap if you keep it down, especially for scraping or web stuff like that. So to continue the demo, I'm just going to list out the ones that are here. I pass in the command list and you'll see it's right there. You'll notice the H0029ILRDK, that's the API ID that Amazon has. So if you want to delete it, you just pass in command delete API ID and then pass in that and it'll delete it for you. It's weird though, they do rate limit you on how many you can delete. I'm not really sure why.
They restrict that.
They restrict that, but you could spin up a bunch of them. So that's pretty much the demo. All right, so I'm going to kind of go through this quickly because we're getting short for time. So far, we found great hosts using those techniques. The portals, we've identified running servers. We got some servers in sight that we're going to focus on. We just need some employees, and we want to change up our attacks a little bit. That's kind of the nature of what we're going to be focused on here. This next section we called social trust attacks because I haven't found anything that really talks about this stuff yet. So there's no real way to differentiate the type of attack that this would be. So what we're going to do is we're going to focus on breaching the organizations, but we're going to be focusing on personal data of the employees. Most employees are trained not to click links unless they know where they came from or if they came from the company email. But what if you received, I don't know, an email from a friend of yours or a family member? And we're also going to look at a couple different types of a different type of a password attack. So if we could get the personal information of the employees, some of their relationships, and then their personal emails, I think it's going to make for a really different twist on these types of attacks. So with that, we're not doing anything new with regard to discovering employees. I mean, this has been done in, I mean, there's a recon NG model for it. There's been so much about, scraping LinkedIn for company people. But how we use that data is interesting. And the thing I want to add here is normally we only care about the first name and last name because we're going to generate like an email address for that user or a username. But this time I would suggest grabbing their city and state as well. We'll get to that in a second. But for email forwarding, I know Bo has a tool, I put it here, email address mangler on GitHub. So if you're wanting to put together like first name dot last name combinations, or if you don't know it, you can go to hunter.io, learn the company email format. I think rocketreach.co has a good one as well. And then, and so take the usernames, or the first name, last name, generate the usernames, generate the email, and now we have company email as well. So aside from all the portals, all the running services, we also have the employees' email addresses, but we need more data. So what we're going to do is we're going to focus on grabbing PII for the employees. We're going to look at, we want to know their personal information. We want to know their personal email addresses. We want to learn about their relationships. In order to do this, I learned about this new, it's relatively new. I guess it's been going on for a really long time. It's just gotten really bad lately. The people data brokers industry. It turns out they buy, sell, trade, they make our data for free and they aggregate it at scale. Like everything you could possibly imagine that's public info, public record, they aggregate and then they make it available and they sell it and they trade it.
Yeah, but it's all secure, right? It's all secure behind, strong authentication, two-factor, long passwords. It's totally locked down, right?
100%. And if you want to try it for yourself, this is just one of them. Go to truepeoplesearch.com and search for your name or your spouse or your whatever, and just look at just that kind of information. It's free. You don't have to log in or anything. You don't have to have an account or anything. But with people like with search places like True People Search, now we could grab the PII, the personal emails, and the relationships because it's all readily available there. I'm going to leave this screen up just for a second. Screenshot this. It'll be in the slide deck. You want to go to each one of these and start opting out. There's a lot more. These are just the most popular. And I want to say that most of them all source from peoplefinders.com, which is the reason why I highlighted it, that one. It seems that PeopleFinders aggregated a lot of this data and they subscribe it out to these different third-party services. I stumbled across this on accident, but I found a really unique ID that was coming back from the web request, but it wasn't being displayed. And I noticed that that unique ID was across all these other sites. So when I cross-referenced the names, it was the same ID. And I traced it back and I found out it was PeopleFinders database. So, but there's way more data. They got people data, they got business data, census, phone data, work data, marriage data, foreclosure data, evictions. They have so much of it. It's all together. We're in for a rude awakening very shortly. And so with that information, this is where it gets kind of fun. So password attacks. I collect data. I collect breach data. One of my biggest databases is a massive, I think it's almost 3 terabytes of plain text credentials that we've sourced from every breach under the sun. Some of that could be like the collection number 1 through 5 that came out. Remember, now we have personal email addresses for corporate employees. So what we're going to do is we're going to go to our breach database. We're going to query our search database for the personal email addresses of the employees and grab their personal passwords. Because what's the chance that people reuse passwords? They do. Historically, we would try to find corporate email addresses in the breach passwords and then hope that they use that password on their corporate account. Didn't always work. We had some luck every once in a while, but doing it from this perspective is using their personal email passwords on their corporate accounts, and it becomes a really bad password reuse problem. And so this is just a little quick tool that I wrote just to kind of, in the beginning when I was testing it, which basically I query almost 300 million people for Bob Barker in Ventura, California. I grab all of the personal email addresses that I find for that Bob Barker in Ventura, California, and then I pull all of the passwords for those personal email addresses, and then we have a really bad day for Bob Barker.
Martin just posted up. He goes, "Thank God for GDPR," and I'm sure that there's sarcasm in that as well.
It's really great, really. I mean, GDPR for Europe. We'll talk about that.
Joel just brought up a great point, and I was thinking about this. He said the local county assessors have websites that you can hook into for free, where you can pull their GIS database and you can see where they live, and that is all public record.
Yep. So imagine all that being sourced. And that's what People Finders is pretty much doing. It's hitting all of those.
Yep.
So this is just a sweet little tool. So here's our attack path. I'm going to real quick highlight. So we found the portals. We scraped employee names and locations. We formatted the corporate emails. We scraped the people sites to get their personal information. We got their personal passwords. We reconciled accounts, and now we're using personal passwords with their corporate emails on their portals. And that's how we basically profit. So quit reusing passwords. That's pretty much the nature of it. I think we all have done that. That'd be a really cool poll. How many people have reused passwords? Now, I know I have, and John, and we talked about this kind of joking around. So social trust attacks. We're getting short for time. I think we could run over a little bit on our interface. So another social trust attack. What if we incorporated their personal information into a phish and we leveraged their known relationships and then tried to doppelgang as a contact? So for instance, let's look at it from this perspective. If I was targeting Bo and I pulled all of Bo's relationships and I seen that Bo had a relationship, some sort of associate with John. And what if I pulled John's associates and I seen that Jason was an associate of John, but Jason was also an associate of Bo. And then I said, hey, Bo, can you believe, hey, it's John. Can you believe what happened to Jason? Man, I can't believe the news is covering him. Check this link out. Boom, done. It's coming from a non-corporate domain or Lakeland Tax Collector. We noticed that your address at, your old address is delinquent. Please review this document and whatever. Boom, done. So we're highly personalizing phishing for using known data. I have a really hyperbolic version of a phish here coming up, but the amount of data that we have is staggering, and we'll use all of this data in a really cool phish here in a second. But we got names, we got aliases. If you had a previous name that you went by, maiden names, and the dates that they were associated, the dates of birth, the age, whether you're alive or whether you're dead, previous addresses, current addresses, the dates that you had those addresses, the phone numbers of the residencies that you've used and the telco provider. We know the neighborhood information, email addresses, relatives, relative types. There's just so much data that we can retrieve using these people data sites that's free, that anybody can do it right now. And so this is just a quick sample. This is Fast People Search, the same data of Marshall Mathers. So if anybody knows Marshall Mathers, would you please stand up?
Would you please stand up?
Yes, please stand up. Please stand up. This is really Marshall Mathers information. There's his phone numbers, there's his current address, there's his email addresses, there's his possible relatives. Look, Kimberly Mathers. It's crazy how accurate this stuff is. I mean, I've been watching TV and I watch some actor or some whatever that's on there on these reality shows, and then I'll go straight to Fast People Search on my phone and just pull up all their personal information. It's super creepy. Pulling up their passwords is even more creepier. But it's all just readily available. This is just a sample. So here's my exaggerated phish. So hey, first name, and you just fill it in the blank. You can automate this whole thing, this whole attack chain. How have you been? It's so-and-so from previous city, and we noticed that, blah, blah, blah. It's crazy how customized you can get with the details from this information when you incorporate it.
This also gets in when you're talking about the phish, the more points of contact that are relevant to that specific individual that you can put into a phish, the more likely they are to click the link that you actually provide to them every single time.
And the worst part here is if I'm doppelganging as your friend, you're not going to expect my email from your corporate email. You're going to expect it from my throwaway Gmail account, as long as it
Yeah.
remotely looks familiar, using his name or whatever. So what can we do? How do we prepare and prevent? We can reduce our digital footprint, right? So watch out for personal emails coming at work or any personal stuff. So whether it's like your tax collector information emailing you at work, that would never happen. But when you start looking at the information, you start seeing how accurate it looks. It gets a little scary, and you start wondering, well, could it really be?
And when you started pulling this together, it was kind of curiosity. You're just kind of pulling in some data, but after a while, it got to the point where it got more and more frightening, right? And you have a reference to your blog post a little bit later talking about just stepping away from Google is just one thing. And then this
Right.
with the GDPR, I think we all need to become Estonia residents.
Right. Yes. Unless you have a clearance. I heard that you have to go back through the clearance process. Somebody from DoD at B-Sides came up to us afterwards and said, I think it does mess with your clearance. So I
Yeah,
wouldn't
those
recommend
DoD
it.
people are just a pain in the ass anyway. Don't listen to them. You shouldn't party with those people.
Yeah. So
According to the JFan 6.3 and the DSKID 6.3 and the ladies, no.
So there was this interesting blog that came out recently. Actually, Brownwind from SANS sent us an email with it. It was cool. It's the Vermont data broker search. So Vermont made it a requirement that if you're a data broker, that you have to register with them in order to do business in Vermont.
So it's a good place to get a list of data brokers then.
That's what we're doing. Yeah, we're aggregating and we're finding out how to opt out. Some of them are through like email, some of them are through a form, some of them you have to mail or phone calls. So we're trying to kind of put a big list together and hopefully do something about that. Or like John said, you could become an e-resident. The cool thing with becoming a European resident is that you can fall under the GDPR, and the erasure clauses are really good. They make it so that they have to delete the data, but they also make it so that they have to notify third parties that deleted data has to be there as well. So if they've shared information with a third party or a partner, they have to delete it as well. I may or may not have a German address and email address and phone number, and I may have walked away from Google and hopefully tried to do a GDPR erasure, but I'm still waiting for that to actually come to pass. But with that, we do, well, I don't know how much time we have for questions. We've answered a bunch of them. I do highlight my journey here with regard to leaving Google. One of the big things that I learned is that putting all of your eggs in one basket makes it really easy for them to track and kind of aggregate and pull together and use against you in some cases. I'm not saying Google is doing that. You'll have to draw your own conclusion on whether or not they're doing that to you. But for me, I have in part one, I had a little experience with Google directly, and then part two, I purged Google from my life, and I outlined the process and undertaking that it was. So it just kind of gives you a little bit of help.
Well, and kind of down the path that you've gone down over the past, I would say 6-7 months, a lot of it had to do with your job, right? Trying to do these types of attacks, doing real red teams, targeting individuals, targeting organizations, setting cloud services against each other. And this gets into a really nasty gray area where you have very, very large organizations, and it's not just Google, right? I think that your journey isn't just like Google is the only thing that's evil. It's like, this is how hard it can be to disentangle one.
Right.
And setting up, like we got into the conversation on Twitter about red teaming and what that's supposed to look like versus a penetration test. And I feel when we're looking at pen testing, red teaming as we're moving into the cloud, that many testers are going to have their hands tied because of the difficulty in dealing with these very large data brokers, dealing with cloud services. And they would much rather us not test anything at Amazon or Microsoft or Google or whatever than actually allow us to test our customers completely. And that goes back to the game is changing. If you're still looking at Active Directory and you're finding all those different pathways, those still are valid. But I would argue within the next 5 to 10 years, maybe even sooner, you're going to see the vast majority of organizations that are in cloud-only infrastructures and their quote-unquote zero trust model. And those are not necessarily more secure. So.
Yep, completely agree. So here's our Twitters if you don't already follow us.
Tweeters.
Twitters.
Yep.
So cool. Any other questions that we had?
Oh, there's been so many questions. We've had, I know Jordan's been on, CJ's here. I've been answering questions. Jason's been answering questions, but it's been a lot of questions. So with that, are we okay if we close it out, gentlemen?
Yep.
All right.
Good.
Well, Thank you everybody for attending, and we will see you in our next webcast. I think the next webcast is from Jordan. Is that correct, Jordan? He's muted right now, but he'll jump on. I don't know what our next one is. Maybe Jason knows, but Jason's got a migraine.
Yeah, nothing scheduled right now, John, but we'll put out an email as soon as we know.
Well, hell, then I might take next week. Well, no, let's start with Jordan's. Jordan has a really cool one that's a step-by-step attack from beginning to end, and attack tactics that instead of PowerPoint slides, he's going to do it live, from harvesting user IDs, password spraying, gaining access to the internal network pivoting, getting a domain administrator account, and then we'll go back and then we'll cover all the defenses. And by the way, defenses to detect a lot of things like Bloodhound and things like that are a train wreck, and we'll cover those. So thank you very much, everybody, and we'll see you in the next webcast. And Mike, Bo, thank you so much for putting this together for us.
See ya.
Thanks, John.